Okay, great. Then welcome to our new release update from Lockup 6.2 today. Thank you for joining. So I think there will still some people dial in. Like always, we record the sessions, and when you have any questions during the sessions, feel free to directly ask them in the Q&A session. We will take them up during the call or maybe in the end. Yes, also today we have quite many new features to report, to share with you. So let's directly jump in, like always in the agenda, what I want to show you today. So let me switch to the presentation mode. Yes, so I have actually a couple of topics that we want to share. The most visual one and most prominent one maybe today is the supply chain map, that we have a new mode, the multi-leg mode. So now we have the possibility that you can actually model your shipments through your whole supply chain easier in the supply chain map. And you also have the possibility to filter on certain hubs to see what would happen, for example, if one supplier fails in your supply chain, which shipments would be affected. And there are actually really multiple topics what you can do with this new mapping mode of the supply chain map. Then, additionally, we also made a further improvement in the Freight Matrix Plus application. In the 6.1 release, we showed you there already that we have now the possibility to compare multiple freight matrices. And now we enhance this, that you can define certain rules, which freight matrix should be applied to which kind of shipments. This is also really helpful and can save you a lot of time, especially if you have multiple providers or different providers in different regions. Then you can model this in the rules in the freight matrix. And additionally, you can also model now fuel surcharges and certain discounts directly in the freight matrix itself. Then the supply chain agent the first version was released in 6.0. Also here we did some great improvements. We support now the scenario comparison. And what is, I think, even more relevant is actually the batch processing, that we can process in batches bigger data and also can run long-running jobs that do several steps for you directly out of the agent. Then the CO2 emission calculation we released in the last release in 6.1. There was also some great interest from many users, and we also directly got some feedback. And we directly made an improvement that we also support now the port control, that you can influence which port is actually used. So currently the whole implementation was that we always use the closest port to your location. But sometimes out of operational reasons, you want to still route through a different port, even if it's not the closest one, for the set that you have actually in your data. Yes, this one I will show you in the CO2, and you can also control now which routes your vessels will actually take in the shipment. This is also new. And then last but not least, but a really big work from the development team, we actually upgraded our solver agent, not our solver agent, our solver infrastructure. The solver is actually the piece of code that is actually running the optimization in the background. It's quite a technical topic itself, but it has a great impact also for all of our applications. So we read through this upgrade to the commercial solver Heaxly. I will also give there some insights about the Heaxly solver later. And currently we support now the Heaxly solver in the applications in the supply chain designer and shipment flow optimizer. These are the two new premium applications. And additionally, we also support them in the matrix creator, network design, and network design plus. So this will definitely have some high impact on the solving time and also of the quality of the results. Okay, perfect. Then as there is quite some program, I directly want to jump in actually in the solution and show you the first part, the new supply chain leg the multi-leg mode. So let's quickly go out of the presentation and directly, like always, into the tool. So here we don't have a new application. It's actually an additional mode in the supply chain map. So if you open now the supply chain map, you can see it that we have now in the address mode and in the lat longitude mode, we have here a new mode called multi-lag. This multi-lag mode gives you the possibility to model actually shipments and the flow of this shipment through your network. The difference is you could also have done this before with modeling it with location and relations, but then each leg of a shipment was independent of each other. So this means, for example, if you filtered on a shipment, it was really difficult to see how the shipment is actually flowing through your network. So I think this will be more visual. It is easier to understand this topic when I just show it to you directly on the map. Before we do this, let's just come to the two input tables. We have one table called the shipment tables. So here I work with the address mode. It's actually the same data that you also have in the sample data when you generate it. The only topic what I did, I enhanced it with a product group and a category. In this shipment table, we define, you have to define a shipment ID to identify the shipment itself. And then the first two columns are actually the starting location and the final location, the arrival location of the shipment. This shipment here, number one, is actually getting routed through 3 different via locations. So this means we start here in China, then we go to another port in China, then we go to a port in Europe, then we go to an additional warehouse in Germany, and then we go to the final customer in Germany. So this will be the path of the shipment itself. Because that you don't have to specify so many addresses in the input table, we decided to model the approach the following. You work here with some location IDs, and this location IDs you define actually in the separate, in the second table. So here, the location name is the same ID that you use here for the modeling. And here you define actually your address. And additionally, you have the possibility to specify the layer, how we visualize this then on the map. In addition to that, you can add here as many optional columns as you want, and they will also appear then in the pop-up later on. But let's take directly a look. How does this look actually on the map itself? I highly recommend you to also work here with the save scenario feature, because then you have the possibility to filter the map. And this opens really some different perspectives in this application if you can filter the map. So I activate here the save scenario. Then the first thing what I need to do, I need to select the workspace where I want to save it. Like always, I prepared here a lockup 6.2. Workspace for the demonstration, and then let's just call this map multi-lag. Then let's run the calculation. What this does, it directly saves the whole data on the platform, and it also enables the map that you can actually filter it. Let's quickly open the map, what actually appears. So in total, just that you know, I modeled here around 900 shipments in our supply chain, okay? These 900 shipments are then directly also aggregated on the certain relations. I will show you in a second what this means. So the idea here of our supply chain is we have a supply chain setup that has some suppliers. Here I can also enable the left side. We have here some suppliers in China. Then we are having actually 2 ports in China, one in Shanghai, one in Hong Kong. And we also have additional suppliers here in Poland, Ukraine, and Romania and Hungary. And we have an additional import port here in Europe, so for the port. And then we have additional warehouses where we do a consolidation in Europe. And we have distribution centers or warehouses in our final destination market. This is here Germany, France, and Spain. And here the purple one, these are actually the customers. So what is important, let's directly enable that we can also click with the map. I also go here in the map settings to make the relations itself selectable, right? To quickly explain how the shipments belong now together, I directly want to show you this with the filtering functionality. When we go here now to a filter, 1 second, because I just did a change in the settings here. Let's just first save quickly the map settings. And then we can go in the filter, otherwise we are losing this map settings. So now here in the filter, I have two possibilities. I can filter on locations. I will show you this in a second, but let's first filter actually on a single shipment, because I just want to explain you what is actually happening in the background here. When I filter now on one shipment and I apply this filter, you see then the whole flow of the shipment with all the separate legs. Even if we only filter on one shipment, if you would have done this with a relation mapping, you would always only have seen one relation. But this shipment that we actually see here has multiple production steps, right? It comes here from China. Let's quickly switch to this 1 second to the different mode, and we can see it easier. So we come in here from China, have here, this is actually going through the port in Hong Kong. The supplier itself is in China. Then we go into our port here in Europe, go to the warehouse in Frankfurt, and from Frankfurt we distribute it to the final customer. So this is the shipment flow. If I click now, for example, here on a certain lane, I can directly see what is actually the flow on this relation, right? What is important to understand, if I release now these topics, if I say here, for example, let's take a look at all shipments again. We always render for you in the background and show you an aggregated version, right? So when from these 900 shipments, there are many shipments who are going from the port in Hong Kong to the port in Europe. If I click itself on a relation itself, I only see, we actually render for you only one line here. So for example, here, this is the line from the below one, is this from Hong Kong. And then I can see, okay, over this route, they are flowing actually 86 of the shipments, and we directly aggregate the total weight then for you. So if you would have rendered this with some relations, and then you would have drawn actually 86 different lines, and if you would have clicked on it, you would just see the result of one of these lines. So now we are actually really doing in the background the calculation for you, okay, how many shipments are routed here, and you always only see the aggregated data in here. So this is actually one part that is important to mention. And additionally, what is also quite helpful, if you want to, for example, make some analysis, how can your supply chain be affected by certain changes? Let's take, for example, a look at this supplier. Here, for example, this supplier is from Ukraine. It could, it's most likely possible that there could be some interruptions because of the political situation. If we go here now and filter on a location itself, then we build the solution like this, that we show you all shipments that are actually affected by this supplier. So even if you filter now on one location, it will be not like this, that you just only see the one location. We show you then directly all the shipments that are actually affected if or dependent on this supplier. As you can see, now you have the map rendered. You can see all markets are affected, Germany, France, and Spain. Here you can take directly a look. Okay, 48 shipments are coming from this supplier. From this 48 shipments, 16 go to Spain, 24 to German market, and the other one is then here 8 to France. So this kind of analysis you can actually also do with these topics. Then important to mention, these names are fully flexible. You don't have to use supplier hub warehouses. You can use the names as you want. You change this here in this layer concept. You can have as many layers as you want in your supply chain and influence it. And then last but not least, we also have here added the product group and a category, right? It's just some generic fields. And this just gives you some additional filtering capability on a shipment level, right? I showed you that you can filter on all of the locations. The same, you can also group this then by this product group and category. And then you can take a look at your supply chain, how the supply chain looks for a certain product group. If we go, for example, now back to the map, we release this one filter. And we go into the shipments table. And here in the end, we have the product group. So now I could, for example, take a look. What is my product group A? How does the supply chain look here? Then you can apply the filter. For sure, you could also narrow down all shipments that are under a certain quantity and so on. This is all flexible. But with the product group, there just the idea is that you have a certain flexible criteria on the shipment level. This could be, for example, reefer, non-reefer product, or any other types of groupage that you want. As you can see, this product group looks like it's only relevant for the German market. So we still have both supplier streams coming in from China, but looks like this is mainly the stream from China to the German market. The other suppliers, they are not relevant for this filtering, so they are actually filtered out. Yeah. So this is actually the new possibility that you have with this new map type, with the multi-leg map type. So if you have any questions, feel free to raise them. If you have any additional feedback, is always welcome. If you would need some additional topics in there or some improvements, just let us know and we try to realize it if possible. Okay, perfect. So this is what I actually wanted to share to the existing topics. So the team in the background, you guys just interrupt me. If there's a question that I should share with the whole round, then just let me know. The second topic, what I actually want to show you today is actually the new features in the Freight Matrix Plus application. In the last release, I explained you already that we have the possibility to compare multiple freight matrices. If you could not join at the last call, I will give you a quick introduction here again. So here on our platform, I have prepared already a workspace. And in this workspace, we have 6 different freight matrices. The freight matrix itself looks like this. For example, this is a freight matrix called discounts -3% Germany. Here you have the freight matrix, and this is, for example, now a distance weight matrix. This means if you have, for example, a certain shipment from 110 kilometers and with a weight of 1,500 kilograms, then you would, for example, fall in this weight class. 110 is above 100. This means you would need to fall in the 120 weight class. And the weight is above 1,000, so you would fall in this 2,000 weight class. This means you would pay for this shipment 225 euro. This is in general how the matrix itself works. This in a regular practical case, you have multiple freight matrices from different providers, and you always want to apply the correct one. And what we supported already since last time, that in one calculation in the Freight Matrix Plus, you can compare multiple of these matrices. What is actually now new? We have now here an additional table, application rules. In this table, you can define now certain rules for which area, for example, this could be one rule, this freight matrix is actually relevant. This freight matrix here is only relevant for the German market. This means the from country needs to be DE. This would be, for example, one rule. There could be also an additional rule that the to country is here Spain. This means that this matrix could be only applied to shipments between Germany and Spain. So this is actually flexible. Maybe just one additional example. Here's a freight matrix where Europe, where we have 3 application rules. And here, for example, this freight matrix is relevant for Germany, Switzerland, and multiple other countries, whatever we define here. This can be also an additional rule. Other rules could be also, for example, what I will show you later, that you have here, for example, in the zip area, a certain rule in there. Let me directly open this one. This is the freight matrix, the zip one. And here we define, for example, a rule that this is relevant for all zip codes that start with 502. If you have a 5-digit zip code with 50212, then it would be applied. If you would have a different zip code that starts with 501, then it would be not applied. So here you have the flexibility to define certain rules. Let's maybe take a quick look at the outcome of the application. And I think then this is also easier to understand this topic. Let's go in here in the freight matrix. I prepared here some data. Let me quickly remove the shipments. I just tested this already before. We will calculate this now together. To use the Freight Matrix Plus, you have some shipments information. It basically has a from address to address. Then we calculate automatically the distance. You have the weight, volume, and so on, all the attributes that are relevant to be applied there. And the application itself is here, this Freight Matrix Plus. The table itself is already selected. What we need to do now, we need to select the workspace where we actually save this freight matrices. This is the workspace that I just showed you on the platform. In my case, this is the Freight Matrix Plus 6.2. And now we are loading actually all available freight matrix in this workspace. And let's just give it a second. So now the matrices are loaded, and now I can select all the one that I actually want to compare. This is still the same what I actually also did in the last release. Now we can calculate this. I selected 6 different freight matrices, and all the costs are actually calculated. Last time I showed you already that we also showed then the best matrix with the best fit. This means with which matrix we actually reach then the lowest price. So this one will be done in a second. So now the calculation is running. First, we calculate the distances. You could theoretically also provide a distance itself. If you don't provide it, then we will calculate. So now the calculation is done. And let's actually export the results. So here in the end, you see now, like mentioned, what the column with the best cost. So here we have actually our final price for each of the shipments. Then we have here which matrix we choose. This means which has actually the best price. This means for a certain shipment, there are multiple matrices that have a fit. For example, for this first shipment, we here have a fit for this matrix discount -3 Germany, for cost Europe, fuel surcharge, regular price, and Turkey to Russia is no fit. And the zip code is also no fit. This means in this matrix here, Turkey and Russia, we have a rule in there that it's, for example, this freight matrix only applies for Turkey and Russia. This you would see here in the beginning because the from country is here Germany and it's not a Turkey nor Russia. So here, for example, the last 3, we would have shipments from Turkey and Russia. And then here we have now a result. So this means we directly apply that rule. If a rule does not fit, we will write not applicable in here. This means you can have all this combination, and then we select actually the matrix that is actually for the correct market. In this case here, for this 3 shipments in Germany, we select then the ones that actually has the best price because the European freight matrix has a relevance and the German one. But in the German market, we get a discount, could be because of some volume, from -3%. How you actually model this -3%, this is actually also a new feature, what I want to show you. When we go now here to the matrix, this discount -3, and you go here to this matrix settings, you have a possibility to model here this discount, 3%, and I want to have a percentage discount. Additionally, you can also do a fuel surcharge, is also highly relevant in the current situation because the fuel prices were heavily increased. There we can take a quick look, for example. Here we have a matrix. It has no application rules. That's why we always have a result with a fuel surcharge of 2%. And here we have actually the same matrix just without this topic. So what we are actually doing here is nothing else than multiplying this topic by 1.2. And then we get actually to this price. You have actually 2 in the fuel surcharge, same with the discount, you have 2 different options. Let's quickly manipulate this. Here's the matrix with the fuel surcharge that we apply. Currently, it's set to percentage. I can also say turn this feature off, and now it would be an absolute value, right? If I save this topic now and run the whole calculation again, then we should not have an additional percentage on top. Then we should have now in the next run just a regular surcharge from €2 if the currency would be euro. Let's export this again. Let's take a look. So now you can see here is the price 1,326, and here is the price 1,328, because we changed it now from a percentage surcharge to an absolute surcharge. So this actually the new topics that we implemented there. To sum it up, the most relevant topic, you have the possibility to model these rules. And the second possibility is that you can additionally make some discounted and this fuel surcharge. Maybe there one topic what I forgot is this SIP use case here. For example, as you can see, we have only 2 shipments where this is relevant. And we go here in front. It makes also sense because, as you remember, we wanted to accept all the zip codes that start with 502, and we have exactly here 2 of them. This one is a 5101, so this is not part of the rule, and for sure all the one who don't have actually a zip codes are also not relevant. This is the third example that I just showed you what you could model. Additionally, just not to forget, if you want, you can also define rules depending on the weight itself. If you have here distance and weight, as you can see here in the modeling, we added here already a certain, like a maximum weight. If you, for example, want to model everything, it's only relevant for shipment below 32 kilograms, because lower than this is a parcel shipment, and you would enter here weight 32 kilograms, and then this would be applied only for shipments that have actually a parcel size. So this one you can also model. Okay, perfect. So that's actually it. I hope I didn't forget anything of the new features in the Freight Matrix Plus. Then maybe one quick check up. Are there any questions currently that we should take up?
No, none at the moment.
Okay, perfect. Then I think we can go to the next topic that I wanted to show you, and this is actually an update in the supply chain agent. In the supply chain agent, I can directly jump into the tool. We can also directly run one topic. Second. So here we can go back to the platform, and we can go to our workspace. This time, because we have now enabled these long-running processes for the agent, I will not make all the examples live because it will take quite a long time. I prepared already some of the examples, but still, while we can still run then in the background some of the topics. Let's go here to in this workspace, this lockup 6.2. where I saved already the multi-leg in there, and we can create here a supply chain agent. So again, supply chain agent is available in the premium topic, and we will make now one batch job for him that he is actually making 2 route calculation, and he will also create us then a scenario comparison. While this will run then in the background, I will show you in some 2 or 3 additional prompts that are also supported now, that we can actually do while this prompt is actually running here. So here I will ask him, can you optimize a route going through the 10 biggest cities in Germany with the start in Munich and also one with the start in Berlin? So you will see now that he works now in this batch iteration, that he can take over multiple tasks step by step, and you see the result, and later he will also do a scenario comparison. So he will calculate now here first the routes with a starting point in Munich, and then he will calculate additional routes. So now you see the first step is actually done, and then this looks like this, that you see actually the execution of the APIs, what technically is an MCP server behind. You see this then step by step. What you can actually also do, and where it's also super helpful that this works now, is something like this. In the past, if you told him, please create me some data, right? Create me, for example, the top 250 biggest cities in Europe by population. Here, after some time, he always had a problem with the precision in this kind of task. So now he's actually working in batches. What he did here, he is creating us now the data step by step, so 50 by 50 rows. So you see here, we make now here 5 iterations, and then later on, we actually have then a data set available with the 250 biggest cities in Europe. So for sure, with this data set, you can also continue then your work, right? So if we go, for example, then here to the next prompt, what I told him here, okay, run now on top of this data that you just created, some center of gravity studies. And here I told him run it between 3 and 5 centers, and additionally do a scenario comparison. So I could also run this now live, but the whole 2 prompts run around in total, maybe around 5 minutes. That's why I don't want to do it live. The other one most likely is still running here. This was the one that we just started. It's also finished. We will come back to the result in a second. But let me just explain you what was actually done here. 1 second. So here he read then the data set to understand again the structure. Then he proposed the mapping, what he did automatically. I just confirmed this to him. And he had some additional questions. Is the population, for example, should he use this as a weight? He also asked if he should set a certain filter on the data set to, for example, exclude Turkey or Russia. And then I said, no, don't exclude anything. And then he was actually running here 3 center of gravity analyzers. And then he did in addition a scenario comparison. So like we showed this already before. So this was the first result with 3 centers. And we have here mapped then with 4 centers and with 5 centers. And last but not least, what is actually also new, we also have now the possibility to run on top directly a scenario comparison. So he can also understand now what is in his workspace, and then he can run on top directly a scenario comparison. And here we compare then the different scenarios in dashboards. And again, you also have this possibility to compare. Actually, then here you would see that the average customer distance is for sure, as more centers you have, is here decreasing in this dashboard, like you would actually run the scenario comparison manually. So this is now also supported. And here, this was now the result that we just calculated. We first did a small route optimization here with a start in Munich. Then with an additional round, the exact same data, just with a start in Berlin. And then again, we here also did the scenario comparison for us. Again, all the results, the agents, like always, he is pushing this into the workspace. And then in the workspace itself, there are actually all the results saved. So these are actually currently the topic for the agent. This is especially helpful if you really have longer prompts. We faced often the problem with this context dilution problem. This means it was then not so precise the answers anyone, and this we got in control, that we have a kind of, don't want to be too technical, but we have in the background a multi-agent system, kind of a manager who is managing then separate agents who are doing the smaller tasks here. This is actually how this works. To achieve that and the better results and to avoid this context dilution. Exactly. Okay, perfect. So this is additional features that we released on the supply chain agent, some improvements. And if there are no questions, I would like to directly continue with the next topic. And there is an enhancement in the CO2 emission calculation for the multi-leg mode. So the multi-leg mode in the CO2 emission calculation we released in the last release in the 6.1. There were also quite some good feedback from multiple customers, and there were also some suggestions that they made totally sense. That's why we improved it further, this application. And this one I actually want to show you. The easiest how I can explain you this topic, so maybe just a quick ramp up for everyone who did not see this new feature. So here, when you go to the CO2 calculation, you have also a mode multi-leg, okay? This multi-leg, you have here shipments. So basically you define from where a shipment comes to where a shipment goes, similar like now with the multi-leg in the supply chain map. And then you can define here multiple transport modes. And if you, for example, have a sea freight shipment, then we route the shipment from your destination location toward the next port. And all seaports are supported that you define actually here in the list. The current logic is always the following. We are always selecting the closest seaport that you actually support, right? Now, there came then the feedback that sometimes this selection is correct, that you should always go to the next seaport. But sometimes there are some conditions that it does not make sense to only go to the closest seaport, that actually you want to have the possibility to define through which seaport you actually want to route a shipment. And this is actually what's new, because we have now here this from port column and the to port column. And here you can actually influence now through which port we are going. So if we take a look at these three shipments, the first one is actually this from port to port column is the optional column. This means we are routing it to the next available port. And here in the next two shipments, we actually fix the port and we tell the system, please route it through this port. But I think the easiest is if I just explain you this topic on the map itself. Let's quickly calculate it. It should be, it is selected. And then there is one more additional feature, and this will I show you with the last shipment. You can also control now, in addition, what is actually the route for the sea shipment. So you can model these restrictions that we also have in the supply chain map. You can also model now here in this multi-leg topic. Let's quickly take a look at this topic. So to explain you these three shipments, I disable this. So if we take a look at the first shipment, then this is this new group type, right? You can also present it last release. You can pack. This shipment is produced with 3 legs. One leg is from the origin to the first port. Then we go on a vessel. Then we go to the next port, and then we go the last step again with a truck to the last segment. And these are actually the 3 segments. So this we showed already last time. And again, this is the same origin destination, only with a different routing. So here he chose the closest port was Rotterdam to Southampton. And if we take now a look at the second shipment, we enforce the solution to not use the port Southampton. We should go to Plymouth. And even if this is actually logistically, it's a detour, but this is still often the case that this happens because you have some additional contracts which ports your provider are using, and now you can actually influence this. And for sure, this detour also has an effect on the CO2 calculation itself, right? So this is actually what's new, that you can fix actually the port and to generate also then these detours in the routing. Then there was one additional feedback. It should be also possible to avoid certain channels, right? So just to stay here with the same example, even in a practical use case, this is often not so relevant. Here we have, for example, the restriction that they are not allowed to cross here between Dover and Calais out of any reason. And now he needs to take here this routing detour. Where this is normally more relevant is this routing restriction here. If you take an example at this channel, that you can avoid this routing. Just to explain how this actually works in the modeling in the Excel, if you take a look here at this column, we have one C standard, and then we have C standard restricted. And this C standard restricted has here now a routing restriction that he is not allowed to drive through this Dover channel. Okay, and that's why he is taking this detour now. And just to show you an example that we also have now the possibility to influence actually the routing of the vessel. Before in the supply chain map, this was already possible, but in the CO2 calculation, it was not possible to model this, and now we also enhance these features. Okay, perfect. So that was actually an update what I wanted to give you on the CO2 emissions calculation. And now, last but not least, I want to show you a quick update. What means a quick update? I cannot really show you the results, but I can explain you the results. And just to highlight which applications are actually affected by this. So these are all the new FREEMIUM applications. This is actually Supply Chain Designer, Shipment Flow Optimizer. Additionally, the network design that is obviously also heavily used, and the network design plus are running on this new solver, Heaxly, in the background, and also the matrix creator itself is also affected. So the matrix creator has also a solver behind. This is currently implemented, these 5 applications. Just that you know, we are currently working on the location planning. So this will come then in the next release, that this also works on top of the SIP solver. To explain quickly what is actually now the difference, we prepared a couple of calculations that we did. So just to frame this, a solver technology is quite a technical topic, but it's actually the basis to solve, for example, these network design problems, or also this time-space networks that is, for example, behind the shipment flow optimizer and the network supply chain designer. This is a general solver technology. The whole time we used an open source solver. It's called SIP solver. This is our existing solver. And now we acquired actually a commercial license of the Heaxly solver. And this is a more powerful solver. After longer validation, we decided to go for the Heaxly solver. There are also a couple of other solver companies on the market, but for our use cases, especially in the logistics, routing, optimization, and also network design, this was for us the best solver with the best performance improvements. So what does this mean actually for your daily work when you use the supply chain apps? So in general, here, what we did just to illustrate this, these are some test results on the shipment flow optimizer. Here we calculated with 500 shipments on top, below with 1,000 shipments. And what you see actually here on the x-axis is the time. This is the time in minutes, how long the solver was running. And this is the objective value, so the target function itself. Because we try to minimize costs, a lower value here is a better solution, just to make this clear. And as you can see, the SIP solver finds, first of all, in the beginning already a much better, not a SIP solver, the Heaxly solver finds in the beginning already a much better solution. And he is also faster in finding a better solution, right? So for example, here the Heaxly solver, after 5 minutes, it dropped already, and he is then still continuously improving. 1 second, let me maybe start this laser pointer. He's then continuously improving actually the result. So the SIP solver, especially here in the 500 case, did not even come close to the same result than the Heaxly solver. So overall, you have a better result of the solution, you have a faster result, and we have a continuous improvement. These are just examples, and it really depends on the model that you just model, right? It's just one of the examples. We cannot say this in general that it behaves for all of them like this. But what we can see here, what is actually consistent, that the Heaxly solver was always faster, finding a better solution. Here in this example with the 1,000 shipments, after 15 minutes, the SIP solver nearly reached the same result than the Heaxly solver. So here it was mainly a speed topic, but then in the end, he was still able to improve it further, while the SIP solver was continuous on the same result. Then maybe one last example. This was, for example, a topic with 2,500 shipments. And here you actually see that the Heaxly solver also had a better result in general. But here it also dropped, for example, with the SIP solver. So what does this actually also affect the topic? So we in the past we had in the support case, right? We had a couple of instances where, for example, your network design model was too big or didn't deliver a result. So many of these topics we could already improve, right? So we had now many calculations that we could not solve in the past. We can solve now, but I also want to be open and honest there. It does not mean that we can solve now everything, right? This is still solutions that are in this area of this NP hard problems. It is definitely really good to have a stronger solver infrastructure behind to solve these topics. And it is good that we could also increase the space or the application size, what we can solve with it. It still does not mean that everything is possible to solve now, right? But it's definitely a big update from our side. And even if it's quite a technical improvement, it's also a highly relevant improvement for everyone who is using the supply chain apps, especially with this kind of optimization functions. Exactly. So this was actually the topics that I wanted to share. So maybe quick question in the round. Are there any questions that we should maybe take up in the big round?
No questions.
Okay, perfect. Then now there is a question, I think. It just at least I saw a hand raised.
Yeah.
So thank you. I was a little. My name is Nicholas Wheeler. I'm actually logistics department in the Fountain Inn U.S. plant. What you have here is, I think, really intuitive, and I was curious if there was a use case for the North American market for this tool to be implemented.
Could you just, if the audio was a bit difficult, can you just repeat the last part? If there is a use case for this one,
the North American market.
Yes, we also have multiple use cases for North American market. Yes, for sure. So this was the apps itself are fully independent on the location, and I think someone from our customer success team can take this up with you, and we can also show you examples in the North American market. Yes.
Okay, cool. Thank you.
Okay, perfect. Are there maybe any other questions? Otherwise, then thank you very much for your time and your attention. And like always, if you have any feedback or any questions, feel free to reach out, contact us via our chatbot or just on support@lockup.com. Thank you for your time and have a great day.